Okay, so again, hey everyone, my name is Bartek. I'm a software engineer at Stellar since 2014. First of all, I would like to thank Satoshi Pay for organizing this meetup tonight. It's great to be here and see a community in real life, so that's cool. So let me give you a brief introduction to what I will show you today. First of all, we'll try to discuss the problems Stellar is trying to solve, why we actually built the project. Then I will quickly explain how it works, and then we'll have some time for questions or a demo. It depends what you want. So we'll see how much time we'll have left after the presentation. So there are three main reasons why Stellar actually exists. So first reason is the cost of financial services. If you have ever sent money across countries, you probably know that the cost of international transfers is really high. Sometimes it's actually connected to speed. It's expensive, but it's also super slow. If you want to speed it up, you need to pay an extra fee to actually make a transaction from, let's say, United States that comes to Europe to be the next day, not the 2 days from now. So basic remittances is one of the problems. Then we have microtransactions. This is something what Satoshi Pay is doing actually. Let's say that you want to sell a song online or an image, and you want to sell it for, let's say, 20 euro cents. And if you decide to do it with a credit card, it's basically not possible because of the fee structure of the credit card payments. Usually, you always need to pay a small base fee that is around probably 20 cents actually. And then a percent of the cost above this initial fee. And finally, there are a lot of people in the world that live for a very small amount of money every day, sometimes even less than $2 a day. And basically, we call these people unbanked because of the fact that no financial institution is able to make a profit to serve these clients, these potential clients. And we believe that blockchain and basically technologies like this that are quite cheap could help solve this problem. Finally, there is this issue with transparency. There are a lot of bad guys in the world, and we really think that making transactions online on blockchain makes it much easier to basically analyze the transactions, track it, and eventually maybe limit or eliminate money laundering and fraud. So these are the reasons, and now let's just dig into the network. Basically, Stellar is a distributed peer-to-peer open source financial platform, and what makes it different from other blockchains is that you can issue an asset natively in the network without the need for building a smart contract, for example. And it also contains a distributed exchange you can use to basically exchange assets. So a simple payment you could do in Stellar is sending money from one account in sending currency, and the receiver in the other country would receive their local currency. And the exchange will happen on the distributed exchange on flight. So when it comes to other advantages of Stellar, I mentioned multi-asset. So basically, everyone who has an account in the network can create a new asset and trade it, sell it, or send it to a friend. Stellar network is very fast. Basically, the algorithm we use to confirm transactions allow us to close ledgers or blocks every 2 to 5 seconds. The fees are pretty low because there is no mining involved in the process. We have compliance algorithms built on top of the network. Financial institution can use to do KYC and AML checks. Network is pretty scalable. You can basically transact thousands of transactions every second. And finally, safety. So basically, the STP algorithm that is used in Stellar allows every node to use other nodes they trust. And basically, it's actually very important in the like in connection to recent events. Not sure if you read the news, but basically this year many smaller mining blockchains were attacked using the 51% attack because of the fact that they are using the same algorithm as Bitcoin, and miners are able to switch to other blockchains and basically, you know, recreate history. So this is super important. Well, actually, I exchanged the order. So when it comes to SCP, I won't talk about it a lot today because it's quite. I don't have too much time to actually dig into the algorithm. But basically, I really encourage you to check the talk by David Mezieres, who is the chief scientist at Stellar. And you can very easily find this talk on YouTube. Just type Stellar Consensus Protocol. The talk took place at Google, so it's super interesting. So let me explain the core concepts of Stellar Network. So basically, the main data structure of Stellar is ledger, and ledger contains the history of transactions that happened in the past. Basically, Stellar core servers that are like the main are like a backbone of the network communicate with each other and agree on a set of transactions they want to include in the next ledger. But what's actually interesting, every once in a while, network also creates checkpoints. If you are familiar with Bitcoin, for example, you know that if you want to check the balance of any given account in the current moment, you would have to download the full history and basically track all of the transactions that are connected to a given account. In Stellar, every once in a while, we actually save the current state of the network, all of the assets, accounts, offers. So if you want to catch up with the network quickly and you don't need the full history, you can actually do it in a very short time. And finally, as I mentioned before, it's quite fast. The network creates every new ledger every few seconds. Next, we have accounts. So basically, accounts are like the main structure that's inside the ledger, and every other object that you can find in the ledger is actually associated with a given account. Accounts are obviously identified by public key of the keeper, of the cryptographic keeper, and basically account can have some entries like trust lines that are basically assets that belong to a given account. Offers are offers that are active offers this account created to and submitted to the distributed exchange. Data entries, these are small chunks of data you can attach to any given account with some metadata or some information to discover certain data about, for example, a given organization. And finally, signers used in multisig. And here's like an example account encoded to a text form. Account ID is a public key of a keeper, represents a given account, and a secret key is your private key you can use to sign transactions and submit them to the network.
Your key?
No, it's actually a random key, but you can check it out. Maybe there's something inside. I don't know. Transactions. So obviously, we need some way to modify the ledger, right? To do it, we like accounts can create and submit transactions, and transactions. The concept of transactions is slightly different than in Bitcoin or other cryptocurrencies, because transactions can also, must also contain operations, and operations are actually the actions that modify data in a ledger. And what is super useful is that transactions are atomic. So this means that if you have, for example, a transaction with two operations inside, either two operations inside will succeed or both will fail. And this allows you to do some simple smart contracts like, bonds, for example, that are pretty easy to do without writing any smart contract code, for example. And transactions can also contain time bounds, which define the period of time when a given transaction is actually valid and can be submitted to the network. And memo is also a very small chunk of data that helps identify transaction or a client of a given organization. When it comes to operations, currently there are 12, and we can group them into 4 categories. Payment operations, these are connected with payments and account creation. Distributed exchange, they allow you to create, modify, and delete your offers in a distributed exchange. Assets are connected with adding assets to your account, but also accepting other accounts to hold your assets. It's not required, but you can configure your account to actually accept which account can hold your assets, for example, for KYC reasons. And finally, we have other operations that, for example, set options on your account, like signers. You can delete your account by merging it with another account, add data, and others. In the very beginning, I mentioned that assets is something that really makes Stellar different. As I mentioned before, every account can issue an asset. It can be either dollar, euros, Bitcoin, stocks, bonds, whatever you like, trading cards in some game. And every asset is defined by an asset code and the issuer. Actually, that's super important because it allows the network to have, for example, multiple USD assets issued by many different financial institutions, right? Otherwise, that would be only one USD asset. There's also Lumens, and Lumen is a native asset of Stellar Network, and it's kind of like a built-in into network from the very beginning. The 2 main reasons for Lumens to exist are to be bridge asset. For example, it's much easier to have a single bridge asset and order books between other assets to this asset, rather than a lot of order books between each other. Obviously, direct order books are still good, but if you want to exchange 2 assets that don't have a direct order book between them, you can use a bridge asset like Lumen to basically be able to trade it all. And finally, there are also fees. I will explain in a second. You are paying them with Lumens. Just one more note connected to lumens. So basically, lumens, you can divide lumen up to 1/10 millionth unit of lumen, and the smallest unit of currency is called stroop, and the name comes from stroopwafels. So that's actually funny. Okay, and finally, distributed exchange allows you to trade your assets with other accounts, and each pair of the asset has an order book between them. Order book is basically a list of offers that are active between two selling asset A and buying asset B, and basically selling asset B and buying asset A, right? After the presentation, I will show you a very nice exchange interface, and you will see it live. Next, we have cross-asset payments. So obviously, trading is one thing you can do on the distributed exchange, but there's something cooler, I think. Basically, you can use existing offers in the network to send so-called path payments. And path payment is a payment that starts with one asset and ends with another asset, right? So basically, when you send a path payment, and as an example, we can send $, and send it to a friend in in Europe that will receive euro. When this payment happens in the network, the USD euro market is actually consumed. The best offer is consumed, and the dollars are sold, and euros are bought, right? And obviously, this is atomic operation. So you can basically make sure that you won't end up in a situation where, for example, you sold your euro, but your friend received no. You send your $, but your friend received no money. What's even cooler is that these paths can have up to 7 assets on them. So let's consider that the market between dollar and euro is super small, or there are like very bad offers, and it doesn't make sense to basically trade because you will lose a lot of money. You can create a path of assets that will basically consumed on these markets one after another, right? So in this example, to make sure that your friend receives euro, you actually send, you sell dollars, buy British pound, then sell British pound, and your friend receives euro. Fees. So that's something I need to mention. There are 2 types of fees in the network. One is the transaction fee, and currently this is 100 stroops. So it's 0.00001 lumen. And actually you pay for 100 stroops for each operation. So if your transaction contains 10 operations, you pay 1,000 stroops. And the other fee is actually refundable. So if you create an account, the network requires the minimum balance of half of the lumen currently. And for each entry, which an entry is trust line or an offer or data entry, you need to hold another half of the lumen for each of them. But as I said before, it's refundable. So if you ever remove your offer or remove a data entry, you can basically transfer these lumens. These are kind of like unblocked, and you can transfer them whatever you like. Okay, so let's say you want to start to build something on top of Stellar. So you know the core concepts, and you finally want to do something. So there's like a brief overview of the software ecosystem of Stellar. So the main piece of software is actually Stellar Core, and Stellar Core is responsible for closing ledgers, communicating with other servers, making sure that the network runs correctly and fast. And on top of Stellar Core, you can connect Horizon. And Horizon is actually a developer server that exposes the REST HTTP API you can use to, for example, query accounts, history of transactions, current offers, order books, and other network-related data. You can also subscribe to events. So, for example, let's say you are building a wallet application and you want to be notified every time there's a payment to your account. You can do it with Horizon. Basically, we have a set of SDKs written in JavaScript, Java, Go, Python, and many other languages. You can use to communicate with Horizon and to build transactions and submit them to Horizon and then to the network. And these are like example applications you can build. You can build mobile wallets, banking applications, payment services, whatever you like. Okay, so if there are any questions, I can answer them. And if not, there is this very cool tool called Laboratory. I want to show you. With Laboratory, we'll create an example account, and then we'll post some transactions with it. So any questions at this point?